Hello everyone, welcome back to Ace Math with Joy. Alright, so this is where we make math fun and enjoyable. And in today's lesson, we will be looking at logarithm part 2. And under this logarithm part 2, we're going to be considering change of base and equations in logarithm. So at the end of this video, you should be able to understand the concept of change of base and then solve all kinds of equations in logarithm. Alright, so first of all, recall the meaning of logarithm. Recall the meaning of logarithm. Now, remember we said that logarithm answers just one simple question. To what power must a base be raised to obtain a given number? Alright, so given that x is raised to the power of a to give us a value b. So logarithm is asking, what must I raise x to get b? And that is a. Alright. Good. So now remember we said writing this in log form becomes the log of b, we maintain our base, is equal to the exponent or the index, right? Good. Now, in change of base, okay, before I proceed, I don't know, you must have been conversant with the use of log tables or the calculator to solve problems in logarithm, right? So if I ask you to find the log of 47.1, what do? Either you press it on your calculator or you use your four-figure table to check 47 under 1. But before you do that, you should know the characteristic, right? So I have two-digit whole numbers here. So 2 minus 1 will give me 1. So that means my characteristic is 1, right? So to get my mantisar, I will check 47 under 1 and then I'll write the result here. Right? Now, I am able to do so because this log is in base 10. So all the things you check in the log tables, you punch on your calculators, they are log 10, in log 10. In that x is raised to the power of a to give us a value b. So logarithm is asking, what must I raise x to get b? And that is a. All right? Good. So now remember we said writing this in log form becomes the log of b, we maintain our base, is equal to the exponent or the index, right? Good. Now, in change of base, okay, before I proceed, I don't know, you must have been conversant with the use of log tables or the calculator to solve problems in logarithm, right? So if I ask you to find the log of 47.1, what do? Either you press it on your calculator or you use your four-figure table to check 47 under 1. But before you do that, you should know the characteristic, right? So I have two-digit whole numbers here. So 2 minus 1 will give me 1. So that means my characteristic is 1, right? So to get my mantisar, I will check 47 under 1 and then I'll write the result here, right? Now, I am able to do so because this log is in base 10. So all the things you check in the log tables, you punch on your calculators, they are log 10, in log 10. So meaning that if I have the log of 7 in base 5, for instance, I cannot punch my calculator. What exactly am I punching? If I punch log 7 on my calculator, it means log 7 in base 10. Do you get? So punching this in my calculator, this is actually what I'm looking for and not this, right? Because what I have on the calculator has been configured to only give us results of logarithm in base 10. The same with the four-figure table. Are you getting me now? Good. So whether I put this base 10 or not, if you just see log using tables, find log 32 0.17. Whether I put the base or not, I've already known that this is in base 10. Are you getting me now? Good. So now what happens in this case where I have log 7 in base 5? What do I do? That is why we need to understand the concept of change of base. So if I have log 8 in base 2, if I have log 8 in base 2, now you see that this base is not 10, right? Now how do I find this? How do I solve this? Now I already know that this 8 is a multiple of 2. So that makes it easy. All right. Then I'll remember what I know in indices, which is why indices is a fundamental knowledge you need to know to be able to understand logarithm. So to solve this, I will ask myself, this is my base, right? To what power will I raise this to get 8? All right. So if I ask myself to what power will I raise this 8 to get 2, I already know that 8 as a multiple of 2 is 2 to the power of 3. So if the bases cancel out, that x will give me 3. Therefore, this is 3, the result of base. What if I have log 8 in base 5? So what do I do? What do I do? That is when it is important that we consider change of base. All right? Good. So now if I have log x in base b, I will use a base common to both. So I will have log in base a of x over the log in base a of b. Now what happens if there is no common base to x and b? I will use base 10. Now let me give you an instance of what I mean by a base common to both of them. If I have log 4 in base 8, now we all know that 4 is not a multiple of 8, right? But both of them are multiples of 2 rather. Since 4 and 8 are multiples of 2, that means they cannot actually have 2 as a common base. So to solve this, I can actually have log 4 in base 2 over log 8 in base 2. So I can actually have log 4 in base 2 all over log 8 in base 2. All right, good. So now in this case, comparing this with this, my a, which is the common log, is 2. All right, so solving this, since 4 is a multiple of 2, for the numerator, I will have log in base 2 of 2 squared over log in base 2 of 2 raised to the power of 3. So if you've seen the last video, looking at the laws of logarithm, the law of the power law, this will come down here, this will come down here. So we'll have 2 log 2 in base 2 over 3 log 2 in base 2. Now remember this law that states that any log in its base is 1. So this becomes 2 times 1 over 3 times 1. And what would that give us? This will give us 2 over 3. Do you see that now? So that means the log of 4 in base 8 is equal to 2 over 3. Now let's consider this case where I can't figure out a common log to the numerator and the denominator. In that case, what do I do? All right. So if I have the log of 20, for instance, in base 5. So the question is 20 a multiple of 5? No. 5 and 20, are they common multiples of a particular number? Let's see. No, they are not. So what do I do? That is when I will use 10 as a common base. So I will have log in base 10 of 20 over the log in base 10 of 5. So this is when I can use tables. All right. So using tables, I'll find log of 20, which is approximately 1.3010, and then also find the log of 5, which is approximately 0.6990. All right. So if I help me divide this by this, and I'll be getting something approximately 1.86. You're going to use your calculator to do this. All right. So you see how I'm able to figure out the log of 20 in base 5. So you see how simple this change of base is, because I hear students complain, this change of base, I don't understand it. So I want to believe at this point it is now as clear as ABC. All right. Now, if it is clear, could you please try these two questions? Okay, so we're going to be solving these three equations in log. So the first one, look at the question there. What do you think we can do? Now, to be able to solve this equation, you need to understand the laws of logarithm. All right. So in the place of this subtraction, we will divide. All right. So looking at what we have on that left hand side, given that there is a common base, which is base 3, so we're going to have 4x plus 1 over 3x minus 5 is equal to 2. Now, what do we do? How do we get rid of this logarithm to be able to solve? Now, we're going to be expressing the right-hand side to a log in base 3. So how do we do that? Now, to do that, we remember that any log in its base is 1. So given that what we have in the question is log 3, so we will have log 3 in base 3 raised to the power of 2. Because this is actually the only thing that would have given 2 on that right-hand side. So if this 2 should come over here, you know any log in its base is 1. 2 times 1. That was actually how this 2 came to be here. So taking this back to this, so we're going to be replacing these 2. So we'll have log in base 3, 1, all over 3x minus 5 to be equal to 3 squared is 9, all right, over 1. So when we cross multiply, we'll have 9 into 3x minus 5 to be equal to 4x plus 1. So when we open up the bracket, 9 times 3 will give us 27x minus 45 to be equal to 4x plus 1. We collect like terms. So collecting like terms, we'll have minus 4x is equal to 1 plus 45. So we'll have 23x to be equal to 46. So since we're looking for x, we divide both sides by the coefficient of x. So x is equal to 3. See, as simple as A, B, C. Okay, now to the second question we have, I think I actually saw two equations to solve simultaneously. So we have the log of x in base 10 plus the log of y in base 10 to be equal to 4. Then the second pair of the equation, the log of x in base 10 plus 2 log y in base 10 to be equal to 3. So I believe that from the first equation, you've seen and understood the concept. So what we will do is to we already know that this plus sign is multiplication, right? Good. So we would change what we have on this side to be in base 10. All right, so we'll have log in base 10 of xy to be equal to log 10 in base 10 raised to power 4. We also have log in base 10. Recall that these two will come over here and this will become y squared, right? All right, so we'll have xy squared is equal to log 10 in base 10 raised to the power of 3. So from here, the bases will cancel out. So what do we have left? So we have xy to be equal to 10 raised to the power of 4, which is 10,000, while we have this to be equal to xy squared 1,000. So we have two equations to solve simultaneously. But then if you look at these two equations, you would see that we don't have plus or minus, rather it is multiplication. All right, so what do? Do we say subtract or add? No, in this case, we're going to be dividing. Okay, if you have equations like this, you divide. So dividing equation 2, can actually do it the other way around. Equation 2 divided by equation 1, we would have xy squared over xy to be equal to 1,000 over 10,000. So here the x will cancel out. This y will take one y here. These 3 zeros will take 3 zeros here. So what do we have left? We have that y is equal to 1 over 10. Okay, so to find our x, we will substitute y into one of the equations. And looking here, the easiest to substitute is equation 1 to run away from the squared, right? So we have x times 1 over 10 to be equal to what? 10,000. Okay, so that would mean x over 10 to be equal to 10,000. So since we are looking for x, we'll cross multiply. And when we do, x becomes 100,000. One more zero will be added. Right? Okay, so we've gotten x and y. I hope you enjoyed that. So very quickly, the last question before I give you a few to try out yourself. We have the log in base 3 of x squared plus 7x plus 21 is equal to 2. So we're going to be doing the same thing. So for the right hand side, expressing the right hand side to be a log in base 3, that is where we start from. So that will be log 3 in base 3 raised to the power of 2. So this will cancel out, and then we'll have x squared plus 7x plus 21 is equal to 9. So collecting like terms, as you can see, we have a quadratic equation, all right? So, quadratic equations are meant to be in this form. So expressing it in that form, we will have x squared plus 7x plus 21 minus 9 is equal to 0. So if I remove 9 from 21, what do I have left? I have 12, right? Okay. So can I factorize? 3 times 4, 12. Okay. 3 plus 4, 12. All right. So that means I can factorize. Okay. So breaking down into 4 terms so that I can group and factorize. Now that I have 4 terms, let's group. So looking at the first bracket, x is common. So if we bring out that x, we'll have x plus 4. And in the second bracket, the sign that is common is plus anyway. 3 is common. If you factor out 3, you have x plus 4. So what is the common factor here? The common factor is x plus 4. And when you bring out x plus 4, what do we have left? Let's throw it in the brackets. We have x plus 3. And then we equate to 0. So your x is minus 4 or minus 3, right? Good. So now with these 3 questions solved, I don't think there is any equation in logarithm that you will find that will not fall into these 3 categories. Either you have an equation, a linear equation at the end of the day to solve in terms of x or y, or any algebra there, or it will land you to a simultaneous equation in 2 unknowns, or it will land you in a quadratic equation. So I want you to confidently look for questions pertaining to this. Lay hands on any past question, you will definitely see these questions. Solve and give me feedback, all right? So before then, could you please try this few for me and drop your answers in the comment section. Invite your friends over to enjoy with us. Thank you on my next video, and do well to invite